Today, we're going to add screen space ambient occlusion to our custom lighting model in Unity. Let's go! Alright, we're in the middle of a series of videos where I've been showing how to create your own custom lighting models. So instead of just controlling the base color, normal, smoothness, and metallic properties, this shader is actually doing the math to calculate diffuse, specular, and ambient lighting. And the really cool thing about that is that you can customize how the lighting works, something that typically can't be done in a node-based shader tool. If you haven't seen the previous videos in the series yet, I'll link the playlist down in the description so you can catch up. Last week, we organized our graph so that we have individual components for diffuse, specular, ambient, and reflectance. It's nice to have it organized this way because we can make alternate versions of these subgraphs and swap them in and out to make variations. Today, we're going to do exactly that. We're going to make a variation of our ambient simple subgraph that supports screen space ambient occlusion. But before we can make a new subgraph, first we need to enable screen space ambient occlusion in our project. By the way, everything that I'm going to be showing today is only in Unity. These are things that I don't know how to do in Unreal, and so I'll apologize in advance for that. Okay, so let's come over to our project here. And we're going to open up our renderer settings. So I'm going to go to our settings folder and pick renderer. And you can see here that there's this button for add renderer feature. And that's where we can enable screen space ambient occlusion. So I'm going to click this and pick screen space ambient occlusion. And just like that, our project now has the feature enabled. Now it's kind of subtle. And so I'm going to zoom in right here to this portion here. And what you're going to do is look at these cracks around the edges. Notice how they're kind of darkened. And when I turn it off, now you can see that the screen space AO went away, and I'll turn it back on. What this is doing is it's creating contact shadows, or areas where the ambient light in the world is occluded because we're kind of down in a bit of a crack. And just to make this a little more obvious, let's change this to interleave gradient, maybe set our intensity a little bit higher, and maybe set our samples a little bit higher as well. Okay, so you can see that with this little lion statue here, if I turn it on and off, it's basically putting ambient shadows in all the little crevices, which is something that's much more realistic, because in those spots on the model, those are places where ambient lighting doesn't reach. Okay, now you may be saying, well, if it already works, what are we actually doing today? And that's a good question. Right now, the shader that I have applied to this model is not actually our custom lighting shader. This is like the generic lit shader that comes with Unity. And so what we need to do next is actually apply the real shader that we've been working on. So I'm going to open this up. It's called Simple Lighting. And I'll apply that to our lion. And now you can see that our ambient occlusion has gone away. We can still see it down here on this plane, on the ground plane, because it's using the Unity lit shader. But our lion is now using our custom shader, and we no longer have our screen space ambient occlusion. So that's why we need to add it into the shader. Okay, so let's go ahead and get started. Now, before we create our ambient simple, there's one mistake that I made a couple of episodes ago that I want to correct. Can you see how these shadows look kind of jaggedy? They're very alias looking shadows. Let's go ahead and fix that. A couple of episodes ago, we added some Boolean keywords to our blackboard, and I actually accidentally made a typo on one of them, and it's this soft shadows keyword here. if we open up our graph inspector, you can see that I've made this word called soft shadows. And this is actually supposed to be shadows soft, right? So if I change that and I save it, now you can see that all of those hard jaggities are gone. All right, so with that fix out of the way, let's go ahead and start. So I'm gonna pick our ambient simple subgraph here. I'll come down here to our folder structure and pick ambient. And I'm just gonna copy and paste this. And for the new one, we're gonna call it ambient simple ssao because we're adding screen space ambient occlusion to it. And I'm gonna swap it out. So I'm going to bring it up here, and we'll connect our normal, our base color, our metallic, our smoothness, our ambient occlusion, and our reflectance. And then we'll connect it up to the rest of the shader. And now we can delete this one. This is our simpler one that doesn't support SSAO. And this one we're going to add SSAO to. So let's go ahead and double click it. The first thing that I want to do, and this is not related to SSAO yet, but what I want to do here is we have our ambient node here that's bringing in our sky color, our equator, and our ground color. And a while back we created this form of ambient, but I want to replace this with a node that's built into Shader Graph called Baked GI. And this node is really nice. Because it handles all kinds of different ambient occlusion. It does indirect dynamic GI. If you're using adaptive probe volumes, it handles that. If you're using gradients like what we have set up here. And if you have baked lighting, it handles that as well. So we're going to swap out this gradient lighting that we have, that we created previously with this baked GI node, because it's significantly more versatile. Okay, so I'm just going to hook up our normals to the Baked GI node. And now we can delete all of these nodes here that were doing our gradient GI previously. By the way, GI stands for global illumination. So this is going to give us some global illumination, some diffuse ambient that's just a little bit more accurate and a little bit more versatile. So I'll go ahead and save that. And now we're ready to work on our screen space ambient occlusion. So I'm going to come down here to the ambient folder. I'm going to right click in here and we're going to create a new shader graph subgraph. And we'll just call this SSAO. So we'll open up our SSAO subgraph. And we need to add one input to our blackboard. And we need to add a couple of outputs as well. So for the input, we're going to make this a vector 2. And we'll call it ScreenPos for screen position. And then for our outputs, we're going to make two float parameters for outputs. The first one is called DirectAO. And the second one is called IndirectAO. So Unity has this idea of these two different types of ambient occlusion. Indirect ambient occlusion is what we normally think of when we think of ambient occlusion. It's the shadowing that happens for indirect light when we're in shadow. And direct ambient occlusion is the shadowing that happens for indirect light when we're in direct light. So looking at our lion statue here, we can see that most of what we're seeing is the direct side of the lion, where it's being hit directly by the light source. But if we come around here to the other side, this is the indirect side. So we'll be seeing ambient occlusion here. This side will be affected by indirect AO. And this side will be affected by direct AO. Okay, so we have our inputs and outputs all set up. Let's bring in our screen position here. And we're going to create a branch on input connection node. For my screen position, we're going to check this use custom binding box and just type in screen position here. And now I can connect up my screen position to input and connected. So when my input here is not connected, we're just going to bring in our screen position node and connect that up. That way, if we don't connect up screen position, the input, it'll just use our screen position node by default. Okay, and now we need to create a custom function node because we actually need to write a little bit of code in order to access Unity's screen space ambient occlusion data. This is not something that we can do with nodes that are built into the system. We need to put some code in that will grab the data that Unity is calculating under the hood and give that data to us. So for our custom function, we need to create inputs and outputs just like we did for our subgraph. So for our inputs, we're going to create a ScreenPos input, screen position, and we'll make it a vector 2. And we'll do the same for our outputs. We need to create DirectAO and IndirectAO. And then we're going to set it to be a string. And for the function name, I'm just going to call it get ssao. And then here in this body area is where we type the code that we're going to be using. So the first thing that I'm going to do here is just set up defaults for our outputs. So I'm going to say our output DirectAO equals 1. And our IndirectAO is also equal to 1. And that's going to give us... Oh, it looks like I made a mistake. I misspelled our input there. So let's change this. It's important to figure out the names of the inputs and outputs so that the code that you type here can match the inputs and the outputs that you've created here. So let me just fix my typo here. All right, so now you can see that error went away. I really like to do this where when I'm creating a custom function node, I add the inputs and then I set them to something just so that we can make sure that the inputs and outputs are working correctly. Well, let's go ahead and hook these up. So this is our screen position coming in, and this is our DirectAO going out, and our IndirectAO going out as well. And now we just need to create the part where we actually fetch those. One of the things that you have to be careful of when creating custom function nodes is that when Unity is creating these previews for shader graph, it doesn't have access to the code that we're going to be using. And so we have to put in some safeguards to tell it, hey, if you're creating a shader graph preview, go ahead and ignore what I'm about to do. And so the way that I'm going to do that is I'm going to say pound if not defined shader graph preview. So if we're not doing the shader graph preview, do this, else do this. And then we'll end it with an end if. So what this structure does is we can put our custom code in this portion here, and it will do this as long as it's not doing a preview in shader graph. But otherwise, for shader graph previews, it's just going to set our values to 1 and 1. Okay, we want to actually add in a couple of more qualifiers here as well. We want to make sure that this code is only run if ssao is active. And so I'm going to say if defined screen space occlusion, and then we need to put in a couple of ands here so that we have two qualifiers. So if screen space ambient occlusion is active and we're not doing a shader graph preview, that's what this little exclamation mark means, by the way. It means not. So, and then the other qualifier that we need is we don't have ambient occlusion on transparent surfaces. And so I'm going to add that one in here as well. So if screen space ambient occlusion is defined and not defined surface type transparent, and not define shader graph preview. Now we're going to do the part where we grab the screen space ambient occlusion. So here I'm going to say float ssao equals, and now this is where I call the function in Unity code where we're grabbing our screen space ambient occlusion. So I'm calling this function called SampleAmbientOcclusion, and I'm passing in the screen position. And then I'm using this ambient occlusion parameter to enable or disable ambient occlusion if it's enabled or disabled at runtime. And then finally, I'm saturating the result and putting the result in this variable called ssao. And now I need to define my DirectAO and my IndirectAO. So let's come down here to the next line. And I'm just going to say IndirectAO equals ssao. That one's easy. Now I can say DirectAO equals, and what we need to do here is, well, let's come over here to our settings again. So if we select our settings and we look at our screen space ambient occlusion that we added just a minute ago, you can see that I have this parameter called direct lighting strength. And what this is doing is it's making our ssao for the direct side, the lit side of the model, weaker or stronger depending on our preference. So right now this parameter is set to 0.25. And what I need to do is take our screen space ambient occlusion and blend between that and 1 based on this parameter. So I'm going to go ahead and do that. So there's my code. I'm lerping between a value of 1 and our SSAO value that we calculated based on this parameter, ambient occlusion param.w. Ambient occlusion param.w is what we're setting with this slider right here. So I've calculated, or I've sampled my ambient occlusion, and I've put that value directly into our IndirectAO. And then for our DirectAO, we're blending between that value and 1 based on this slider parameter here. Okay, and I will link this code down in the description below so that you don't have to like squint at your screen and try to figure all of that out. You can just copy it and paste it from the description. Okay, that should do it for us. Let's go ahead and save our SSAO function. And we'll switch back to our ambient occlusion subgraph here. And now we need to bring in our subgraph and connect it up to the rest of the graph here. So we have our screen space ambient occlusion. We have our ambient occlusion coming in here, and this is the ambient occlusion that would be in the material. And so what we need to do is combine our material ambient occlusion with our screen space ambient occlusion. So for indirect here, I'm just going to pull out a wire, and we're going to find the minimum. Whichever of these values is darker, that's what we're going to use for our ambient occlusion. And so I'll just connect that up right there. And for our direct ambient occlusion, we actually need to wire that out. We actually need to wire that up somewhere else. So what we need to do here is add a new output. So I'm going to open up our graph inspector here. We have our ambient output there, and I'm going to add a new DirectAO output, and it's a float. And now we can connect up our DirectAO to that. So we're calculating our SSAO here in our ambient subgraph, but the DirectAO is something that we need somewhere else in the graph, so I'm just going to pass it out. All right, so let's go ahead and save our simple SSAO. So we have our simple SSAO here, and we're multiplying our diffuse ambient by our SSAO. So let's come around here to the back side of our lion and see if we can see our ambient occlusion. If we toggle our ambient occlusion on and off, Oh yeah, it's working really well. You can see it right here in the crevices. If I toggle it off, now it's gone, and now it's there. Okay, we need to do the same thing for the front side of the lion, though. So let's go ahead and wire up this output here called DirectAO. So in order to do that, it's pretty easy. We can just come here to our diffuse light that's coming out of our additional lights subgraph. And we just need to multiply diffuse by our DirectAO. So I'm going to add a multiply node here. And then pass our DirectAO into that. And connect it up. And if we save this, now you're going to be able to see the ambient occlusion on the directly lit side of the lion as well. So let's go ahead and just kind of toggle it on and off so you can see that. Yeah, perfect. So we're getting our AO just like we wanted. Okay, so that's our new version of Ambient Simple. It's calculating our screen space ambient occlusion, bringing it in and adding it to the lit side of the lion and the unlit. Oh, there is one other thing I guess I can show you, and that is that this parameter here, this direct lighting strength, because we took advantage of that, we added it into our code. Now if I dial this in and out, you can see how it's affecting the ambient occlusion. I can make it stronger or weaker depending on this parameter setting. So that's pretty cool. That's how you create a subgraph that brings ambient occlusion into your custom lighting model. The way that I've implemented it today is basically a copy of what Unity's built-in lighting is already doing. But the nice thing about this is we could bring in ssao like this, and we could have our ssao do something else. You know, we could make it create more saturated color down in the cracks, or we could make it add dirt and grime down in the cracks, or all kinds of other things, because we have access to this screen space ambient occlusion data. So I hope you enjoyed today's tutorial. That's how you add ssao to your custom lighting. Okay, next week, when we did the episode on creating our additional lights, a lot of you asked if I would show how to support Forward Plus, because right now our renderer is just set to Forward, and if we set it to Forward Plus, it's going to have some problems with our additional light sources. So I think next week I'll show you how to do that, and maybe a couple of other surprises as well. So be sure to come back next week. Anyway, I hope you enjoyed today's tutorial, and have a great week, everybody.